Implementing a Wi-Fi network. These are the points we are going to cover in this section. How to design a small wireless LAN, and how to install and configure access points and clients on larger networks. Larger network like this college network, which has multiple buildings, and every building is having the same network and providing Wi-Fi access to their devices. So first of all, you need to identify the design. So if it is a small or home office network called SOHO network, might call for only one access point, and it is generally the case in your small home. So whatever the size of the home is, we do not usually have multiple access points. We have just one access point placed conveniently at a location where you feel like it is the central place of your house, right? And the access point device often combines switching, routing, and other network functions. So that is what ADSL router is doing. So your ADSL router is basically doing all these functions. It is, as I said earlier, your ISP and your home. In between your ISP and home, this ADSL router is sitting here. So this ADSL is connecting to your to internet, so it is doing the job of routing. Remember, it is connecting two different networks. This is your private network and this is a public network. So connecting a private network to a public network, we always need a router. Or if I am connecting to two different IP addresses, a network using two different IP addresses, we are using a router. By the way, where do you use switch? Where do you use switch? What's your name?
Richard.
Richard is saying LAN. David, Sam, Joe. What's your name? Antonio. Abil? You're Abil? What do you know about switches? Benjamin, what do you know about switches? Okay. Wherever. So basically, switches are when I'm saying router is used to connect two different networks, so are we using switches also for the same purpose?
Yes.
No. We are using switches only to connect the devices within the same network. Switches are only used to connect the devices within the same network. What type of topology we create using switches? Anybody? Star. We create star topology using switch. The switch is even if the switch is lying in one corner and your devices are connected to the switch in this way only, even then it is a star topology. It doesn't look like a star, but switches always creates a star topology. So whatever way devices are connected to your switch is a star topology, even though it does not look like a star. Right? So switches are used to connect devices within the same network. Routers are used to connect devices to different networks. Two different networks. One is either, even when I say public and private, definitely we need a router. But even if I have two private IP addresses, private network, there is a private network, there is a private network. You want to connect both. This one is using 172.16. This one is using 192.168. You want to connect both these. What do you need in between? A switch or a router? You need a router in between. Okay? Remember this thing. You need a router in between if you want to connect these two. So please study more about switches and routers if you are not still confident or comfortable what the switches and routers are. So watch some videos. I'm not saying that watch hours and hours of videos, just Few minutes.
So the internet service provider provides different public IP address for each person, right?
For each router.
For each router.
Right? See, that's your home router. It has one connection goes to ISP, which always coming from outside your home, right? And then it is sitting here inside your home, transmitting the Wi-Fi signals. Transmitting the Wi-Fi signal. So it has two interfaces. This is the interface which is transmitting the Wi-Fi signal, and there are a couple of RJ45 also. So this interface which is connected to these RJ45 and this connected to these all Wi-Fi signals. So there are two interfaces here. One is this which is public, another one is this which is private. So it has a public IP address, it has a private IP address. Now all the devices here are connected to these RJ45s. All these devices are also using a private IP address which is the same series as this. These all private IP addresses are same series as this IP address, but these all are using a gateway. These all devices are using a gateway, and that gateway is the IP address of this interface.
Sacrum.
The gateway's IP address is the IP address of this interface. Now a router which is sitting inside this device is connecting this network with this network. A router which is sitting, now you must remember how we did the exercise last week. The router connecting two different networks. This network was 172.16, this network was 192.168. If your computer here, this interface having the IP address from 172 network, this interface having the IP address of 192 network. Until you, so let's say this IP address does not there. So if you are trying to send the signal from this computer to that computer, it does not work. The moment you set the IP address here 192, which belongs to this series, the communication establishes, because the router started passing the signals from 192 to 172. So router is like a connecting device between the two different type of networks. Either they are different in terms of IP address, or they are different in terms of medium. Medium means Wi-Fi and cable. That is also converting.
So modem is different from router then, right?
That's right.
Okay.
Now where the modem comes into the picture? The modem comes after this. Here. Modem is sitting somewhere here, where it is converting the signals into electric or electric into, data into electric signals and signals into data. Now many IoT devices can be connected to the network. Consider the following when deciding where to install APs, like distance, type, number of obstacles, coverage, interference. So they decided to install two APs here in this room. One is here, one is there. Why they installed it at the corner of that room? Why not in the middle of the room?
So it becomes part of the hall.
Right, so it covers the hallway. So that device or that AP can also cover the hallway, people working in the hallway. Try to look at these access points whenever you go to buildings to building, classroom to classroom, see where these access points are installed. What is their locations? What is the distance between? If I have one here, one there, do I have, where is the another one on that side of the building? There are classrooms on that side also. In the gaming classroom, if you ever get a chance, or you can go any time if the classroom is free, and see how many access points are installed there. But if you want to go into the details of your signals or the connections, then you can also find right now which access point your device is connected to. Is it connected to this access point or to that access point, or the access point in the hall, in the lobby, or the access point in the next room? You can check that, but you need to know some advanced tools for that. Okay. Larger WLAN warrant a more systematic approach to access point placement. So you need a proper design for that. And you need to know the specifications of these access points, like how much area these access points can cover with good signal strength. Right? So is the person sitting just below the router, or the person sitting at the corner of this classroom is getting same signal, or they are getting different signals? Based on that, you can decide how many access points you should install in a particular area. You can also do the wireless site survey to assess the client requirements, facility characteristic, coverage area, like how the facility is constructed. Is this facility using normal sheet rock walls, or the concrete walls, or the iron walls, or the glass walls? What kind of walls this building uses? Based on that also you can decide how many access points you need to cover the entire building. Finally, a thorough site survey might include the following points. So you can look at these points. Then configure the Wi-Fi connectivity devices. So while you are configuring your devices, access points vary in which wireless standards they support, their antenna strength, and other features. Make sure that the standards, all the access points in your area, in your network, are using same standards. The variable set includes following. So every access point is having these characteristics or these values to be provided. What is the administrator password, SSID, and whether or not the SSID is broadcasted, security options, whether or not DHCP is used. So all these are the options you set in your Wi-Fi device or the connectivity device. Now these access points are different from those you are using at home. These are just the repeaters. They are not the one which you are using at home. Okay. You can't say that, okay, if I remove it from here, can I use it at my home? You can use it at home, but it also needs a router in your house. It can only connect to, can you see there is a blue wire going into this? If you can see it carefully on that side or this side, these devices are connected via wire to the network and then transmitting a Wi-Fi signal. So these type of devices generally known as repeaters. They are only converting your wired signal into Wi-Fi signal. They are not doing anything else. They are converting your wired signal into a Wi-Fi signal. Whereas the device which you have at home is doing modem job, is doing router job, is doing a switch job, and is doing the job of this device as well, which is converting your wired signal into Wi-Fi signal and vice versa. Receiving Wi-Fi signals or Wi-Fi data from the computers or mobile devices and sending it to the wired network, or opposite to that. So that router which you are using at home is doing a job of 4 or 5 devices together. This one is just one, converting your wired signal into Wi-Fi signal. That's it. So when you are configuring your Wi-Fi connectivity devices, you need to change the administrator password. Most of the time, we are using the same password what is printed on the back of the device or what is provided by the service provider. We never bothered about changing the password of our Wi-Fi device, which is not a good practice, because that password is actually recorded somewhere in someone's system and can be compromised. So better you change the password of your Wi-Fi device. SSID means you have to give a name. Again, most of the people are using the same SSID what is provided by the manufacturer. So you may see a lot of names around your house by the name of AT&T, by the name of Spectrum, by the name of Xfinity or Comcast. They do not use or they do not change to some custom name, which is always a good practice. Change it to some custom name. Security options, there are multiple security options. Security options means how would you like to secure your network? And there are 4 or 5 different methods of securing your network. I think it should be there in the next few slides. That is basically the way you encrypt your data. How would you like to encrypt your data on network? That is the security option. And whether or not to use DHCP. What does it mean? It means to assign the IP addresses to all the connected devices in the network. Would you like to use DHCP here? If yes, which is always a best practice, then the device will automatically assign IP address to all the connected devices. Have you ever need to assign IP address to your phone? No. Or to your laptop? No. It is automatically assigned. You come here in this building, you get an IP address. You go back to your home, you get an IP address. They are same? No, they are not same. But for a particular number of days, they may remain same. For example, you are coming here every day. I'm coming here every day. So whatever IP address my phone receives, it remains same for next maybe 30 or 45 days. For your home also. Because my home network is not very big. It has, let's say, maybe 32 IP addresses maximum. So within the IP address range of 32, I may be getting 1 or 2 IP addresses again and again and again. It does not change a lot. So you can set, which is always a good practice. You should always use DHCP. Because otherwise you need to assign IP addresses manually. And what is the most common problem in manually assigned IP addresses? Anybody?
Duplicates.
Duplicate. Right, same IP addresses are duplicate. Right? And if something goes wrong during your server router configuration, you can force a reset. So these devices always has a button, a small button, which you can press, and a device goes back to factory setting, like your phones. Your phones has an option to do a factory reset, right? But does it has a button or it has an option? It's an option, doesn't have button. But these devices, they have a special button. Either you need to press the button using a pin. So you have to poke a pin, because the button is not the button which is like a switch button. So you have to poke a pin in the hole and keep it pressed for, let's say, 3 seconds or 10 seconds, and the device will go back into the factory reset. And then you can redo everything on your device. So if you ever mess up with your device, so don't get panicked. You can always do a factory reset and the device will go back to its default setting. Configuring Wi-Fi clients, and this part everybody knows that how we can connect to a Wi-Fi network. So onboarding involves the installing a specific program or app onto the device, give it trusted access to certain portion of a network. So it is like how you can connect to a network, that is onboarding. And offboarding, you don't need to do much. All you can do is disconnect. If you want that your device should never connect to a network, what you do? if you want that a device should never connect to a particular network, Wi-Fi network, what you should do? Huh? Cut it off?
Remove the network cable.
Remove? No.
Reset it.
Huh?
Reset it.
Reset it? No. I'm saying, let's say, there are five different Wi-Fi networks. Your device is connected or sometime connected to one of those networks or all of those networks. There are 5 Wi-Fi networks. Your device connected in different places. This one is in college. This one is in mall. This one is home. This one is airport. This is another airport. Now you want that your device should never connect or never connect these airport networks ever in future. So what you do? What option you have in your device so that your device will never connect?
Forget.
Yes. Forget. Very basic, simple things. Forget your network. Or let's say you put the wrong password in your network and it is not asking you the password again. So again you can try this forget network and then it will start considering it as a new network for your device. So forget network, it doesn't mean that your device will never show this network again. But forget means if you have any settings saved in your system for the network, delete all the settings. Delete all the settings of that network. Okay. And you know what it is? So this offboarding involves removing programs that gives these devices a special permission on the network. And administrator need a feature that allow them to offboard remotely, and the feature is called remote wipe. That is offboarding. Wi-Fi network security. Now this is very important and this needs to be understood very carefully if you are doing cyber security. So by default 802.11 is the standard, offers no security. Means when the 802.11 was released in its original form, there was no security at all. Then later we added a lot of new security features to this standard and we add those additional sub-standards in this one standard of Wi-Fi connections. Then authentication, you know what is authentication. MAC filtering. I can say that following MAC addresses should never connect to this network. Now, do you know one feature about MAC address? How many sections are there in MAC address? 6. 1, 2, 3, 4, 5, 6. 2 digits, right? 2 characters here, 2. Do you know what is the use of these characters? This is for manufacturer ID. This is the manufacturer ID and this is the device ID. So if I want that all the Dell computers or all the Apple computers should never connect to my network. All Apple computers should never connect to my network, so it is very easy with the help of manufacturer ID. I can filter all the Apple computers out of my network and they will never connect to my Wi-Fi. All the Apple iPhones, all the Macs will never connect to your network. Or if I say I want that my friend's computer should never connect to my network, so then I will look for device ID. If I know his or her device ID, I can block his or her mobile phone or computer from my network. So it will never get connected to my network. Then we have various encryption algorithms used in these communication channels. And you know what is encryption means. I don't want to explain that, but it always need an algorithm. And that you can select from the window, like what kind of encryption you would like to use in your network. Okay, see, more rigorous encryption is more impact on the performance. So if you feel like your data is very sensitive, and you should keep it secure, then only you should use a heavy encryption algorithm. Otherwise keep it light. Otherwise keep it light or keep it simple. Okay, there is no spy sitting outside of your house in his or her car and hacking into your network and stealing all your data, bank transactions and all. Right? It's not, we are not that valuable assets or resource to anyone in this world. If you are, then I don't think. You can better decide how you're gonna protect your data, your network from anyone. Now these are the various algorithms we use for authentication and for encryption. One is called WEP. It offers two forms of authentication. One is called OSA, Open System Authentication, and another one is Shared Key Authentication. So I would suggest that you should search for some videos, take the help of AI, search some videos on OSA and ISCA, and watch those videos. Then WPA. So one is WEP, which is Wired Equivalent Privacy, which is a very, I would say, very basic one. Because WEP does not offer end-to-end data transmission security. WEP has replaced with quick fix by WPA. So WPA is the next level of WEP. So WPA, and it is very commonly used by Wi-Fi networks, WPA. It's dynamically assign every transmissions its own key. Means every time you are establishing a communication. See, communication doesn't mean that every time you are sending data between two devices is a communication. Communication means once you started a communication, it will remain one communication until you say bye or you close that communication. Say you opened a website, you opened a Blackboard on your computer and you started working on your assignment, quizzes, labs. So the communication is still the same. The moment you close your Blackboard, that communication stopped. So until one communication is going on, it is going to use a key. And it incorporates an encryption key generation and management scheme known as TKIP, or Temporal Key Integrity Protocol, which is basically offering you the following features: key distribution, encryption, and message integrity, keeping your communication safe and secure all the time. Then comes the WPA2, which is the previous thing, but more enhanced features of security, and it is using CCMP, which is counter mode with CBC, or cipher block chaining. So more encryption is now added, more rigorous encryption or security is added to your communication, and it is using AES, or Advanced Encryption Standards, for encrypting your data. Then comes the WPA3, and there are few other algorithms we have, and that you can see on different videos. The picture is somehow not displaying, so you can watch in your systems. Some other security configurations, such as your AP and antenna placement, geofencing, guest network. These are some terms. Yes, I would say that look at these terms on some AI portals. Talking about them is not that feasible here. What is geofencing? You can fence yourself, or signals should not go beyond that limit. Guest network. You can create a guest network in your Wi-Fi router. Say you don't want to share the password of your network to everyone visiting your house. So what you should do? I can create a parallel guest network, right? Your router is supporting two types of channels, 5 megahertz and 2.4 megahertz. 5 megahertz is fast speed, 2.4 is slow speed. You don't want to use your friends or your visitors, you don't want them to use 5 megahertz, you want them to use 2.4 megahertz. So you can create a guest network, right? And similar to captive portal, wireless client isolation, IoT access considerations and all that. These days, a lot of IoT devices we are using in our home, and those IoT devices are also being used by different service providers. So that means those service providers has some level of access in your network. Is that connection secure? Or is that communication from other party secure? So what kind of access those IoT devices have in your network? You can do that as well, or you can control. These are some security threats to Wi-Fi networks such as war driving, war chalking, evil twin. So read about it. Read about these two, these also. WPA attack, WPS attack. You will learn more about it in cybersecurity classes as well. These are some tools which you can use in your Wi-Fi, such as a spectrum analyzer. So a device that can access the quality of wireless signals, you can use these applications online, or you can download them as an app on your phones. Wi-Fi analyzers, software that can evaluate your Wi-Fi network availability. You must be using a speed test. Anyone? Speed test? Anyone using a speed test ever? It's a very common application available online which you can use. It is an app. It's an app also, and you can download that app on your phones and you can check what is the current speed you are getting, upload and download. So that is the download speed of almost 1 gig. Download speed of almost 1 gig, and after download it will show you, or it will test the upload speed, and this is the upload speed of also almost 1 gig. Right, so 940 Mbps download speed and almost 940 Mbps upload speed. So you can also check on your phones. There's an app. You can download this speed test, or you can try it online. You don't need to do it on an app. Avoiding pitfalls. So some of the issues which you can avoid, such as no connection, when you can't get the Wi-Fi client to connect to the access point, consider the following common issues like wrong SSID, encryption protocol mismatch, incorrect passphrase if you are using passphrase. Passphrase are used generally in a highly secured network. Right? Static channel utilization, mismatch RF band, mismatched standards, installed AP association. So you can try it by forgetting your network. If you are facing this kind of issue, simple is, first of all, forget the network and try connecting it again with the new credentials or correct set of information. Some other pitfalls for slow connections. So you are at the very far distance, far location from the Wi-Fi. For example, when you are leaving your house, and if you are watching a video and you are exiting of your house, then video will stop for a while. It's a very common phenomenon. Video will stop for a while, and the moment you get connected to your service provider's network, then it will start again. So all these are common issues. Okay, so that's all about this chapter. Okay, let's see how many of you are going to complete this activity. Okay, everyone start your packet tracer.
Is this the first packet tracer?
Huh?
The first packet tracer?
First please. The first, what do you mean by first? Sorry.
I mean, isn't there like packet tracer 1 and 2?
This is the exercise here. This is the video
Oh,
actually.
okay.
Yeah. In the chapter 6, this video. But I'm asking you to start the packet tracer application on your systems. Yes, Cisco packet tracer and log in into it using your login ID and password you created. Okay, so I'm not logging into it right now.
Hi, all. I'm Jill West, author of.
Okay, so once you are ready, please raise your hand. Once you are ready, please raise your hand. Okay. Ready? Okay. Okay. Now you can put down. Ready? Make sure you know what is your user ID and password. You must have created in the packet tracer activity. What happened? Create an account later, okay? It's very simple process of creating an account.
I'm saying it's not letting me like select the country, like I was having the same issue last time.
The CompTIA Network Plus course from Cengage. In this video, we'll be working through the project, create and secure a basic wireless network.
So this is the one thing if you can achieve in this semester or in this course, that you learn how to use packet tracer, and you learn, because rest of the things AI can do. AI can calculate the IP addresses for you, AI can do subnetting, IP subnettings for you. AI, with the help of AI, you can know what service is using what port. If I want to know what is the port number for Telnet, I can simply ask AI or I can search it on Google, fine. But if I ask, if you want to suppose, let's say you want to create a network, you want to test a network, how that network gonna work, AI may not be able to do that for you as of now. Maybe in future you will have some kind of tool for that as well. So if you learn one thing here in this semester, how to use packet tracer, rest of the semesters will be easy for you. And I'm telling you, if you get some interest developed in this application, this packet tracer application, then you can learn a lot of things about network using this application.
Network and packet tracer. Now, as you know, wireless networks present some unusual challenges for securing our wireless transmissions. In this project, we'll explore some of the options we have for securing wireless connections. So let's get started. One more reminder, just make sure you're starting with a brand new network file and you're not using your previous network file that we created for another project. First, we need a wireless router. So here in the network devices category, we need the wireless devices group and then select this WRT300N wireless router. So click on it and then click up here to place your device. We need to make some configuration changes to this router. So I'll click the router and let's move this around. Make sure you can still see your network as you're working on these configuration changes.
Okay.
So I'll click the router and then click up RT300N.
Okay, so you are going to pick RT300, WRT300N.
Wireless router. So click on it and then click up here to place your device. We need to make some configuration changes to this router. So I'll click the router
Click the router and you will get this kind of window.
and let's move this around. Make sure you can still see your network as you're working on these configuration changes. We're going to the config tab and
Okay, going to the config tab on this router.
we need to work on the LAN facing interface. So
Click on LAN.
click LAN right here, local area network. First, we need to give it an IP address. It's almost the same as what's already here. So you can just change that 0 to a 5.
So you can follow the IP address as suggested in this video.
We want this address to be 192.168.5.1. The subnet mask is still correct. It's a /24 255.255.255.0. Okay, minimize this window and we're ready to add a laptop that will connect to our wireless network. So in the end devices category, grab a laptop right here, place it in your network space, and we actually need to make a change to the laptop's physical configuration. So if we zoom in a little bit here, you can see on this laptop, it has a wired network interface, and we're trying to establish a wireless connection. So we have to remove this interface module and then put in a wireless interface instead. So first you need to turn off the laptop, make sure you click the power button over here, and then grab this module, drag it over here to the modules list, and we need this WPC.
So you notice what you did?
Off the laptop, make sure you click the power button over here, and then grab this module, drag it over here to the modules list, and we need this WPC300N wireless module. So grab this one, drag it to that empty slot and drop it there. You can see now it has an antenna on that space so that it can establish the wireless connection. And make sure you turn the laptop back on, and within a few seconds, you should be able to see on your network that a wireless connection is automatically created.
Right, so wireless connection is created.
The reason it could create a wireless connection just automatically like that is because we have no security configured on our wireless router. So let's change that. Click your wireless router, and on the config tab, we're going to the wireless page to make some changes to the wireless security configuration. First, we want to change the authentication type. It's currently disabled. Let's change it to WPA2-PSK, which is the most secure option that's available here without having to use some sort of authentication server. Now, theoretically, we could use WPA2 with a radius server, and you will do that in a later project, but that's not typical for a home network. So this project is intended to replicate kind of what you would do more on a home network. So WPA2-PSK is our better fit here. We need to give it the passphrase network plus, of course, this would not be a secure passphrase.
Passphrase is like a password. Okay, passphrase. Passphrase is not exactly password, but I would say passphrase is like a key for the encryption. So you are setting a key so that the data, whenever the data will be unencrypted, so if it is asking for a passphrase to unencrypt the data or allow anyone to connect, it will ask for the passphrase, and that is the passphrase you need to provide. Somewhere you may have a password and passphrase both. Somewhere you just need a passphrase, password.
To use for a real network, but it's easy to remember for this project. Make sure your encryption type is AES, which is the most secure option of the two given here. TKIP or TKIP is a less secure option, so we're choosing AES, Advanced Encryption Standard. And notice, now that we've configured this security, our wireless connection is lost. So to reestablish the wireless connection, we're going to need to give our laptop the security information it needs to authenticate to our router. Let's go back to the laptop's configuration window. We need the config tab up here at the top, and we're going to its wireless interface, which is the interface that we installed in the earlier step. Let's give the laptop the authentication information that it needs. So we're using WPA2-PSK. The passphrase is network plus. And once you click out of that field, so the information is implemented, you can see that the wireless connection is automatically reestablished. If it doesn't, then you need to troubleshoot and see what's missing, what you need to change in order to get this wireless connection reestablished. Now, if you were working with a router in your own home network, typically you would have a lot of other configuration options. So let's go back over to the wireless routers configuration page and see what other changes we can make. We need to go to the GUI tab, and then this looks actually very similar to what you might see with certain brands of home routers and wireless routers that you could use in your own home network. You can see you have menus within menus, pages within pages in order to make these different changes. What's some of the information that we have available to us here? We can see that the router is using DHCP to hand out IP addresses. Its own IP address is what we said at the beginning, 192.168.5.1. The DHCP server is using a range of IP addresses from 192.168.5.100 through 149. How long does a client get to keep its IP address once it receives one? This is where you would be able to change that information because it's already set to 0. 0 is defaulting to 1 day. Let's go to the wireless settings page. So we'll click wireless up here. We're on the basic wireless settings page. And here we can change the SSID. That's the name that the wireless network is broadcasting to identify itself so that clients can connect to it. Right now it's just default, and it's always a good idea to change the default SSID for your wireless networks. We're making this one to be Happy Vintage, all one word. Now, as is common for these configuration pages for home routers, you need to scroll to the bottom and make sure you click Save Settings in order to implement your configuration changes. Watch what happens to your wireless connection once we make this change. So I'll click Save Settings, and the wireless connection immediately goes away. Before we fix that, let's take a look at our wireless security just to see what it looks like on this particular interface. So we have wireless security page right here. You can see we already have selected WPA2 Personal. You can see our other options are listed here as well. AES, remember we had the option between AES or TKIP, TKIP. We have our passphrase here as well. And we're finished with this window, so let's close this one. So how can we fix this situation to get our laptop reconnected to the wireless router? Let's go back to the laptop's configuration window, and we need, again, on the config tab, we're on the wire.
My only objective is that you should do all these activities, not just watching video, but also doing this activity on your packet tracer application. Okay? If you really want to learn something about network, making a network, creating a network, setting up a network, then this exercise is very much important. It's more important than any other activity you are doing in this course where you are getting some grades, right? This is required for passing this course, right? This simulation is required to pass this course, but this activity is required for all future programs you are going to do in your major, especially if you are a networking major or you are a cybersecurity major. So it's a future readiness. Rest is all on you because no one can force you to do what to do and what not to do. Okay? All right. So keep learning and see you next week.
So that's that?
Yes, sir.
Okay.